Now in question number 14, the question is a boy has 231 marbles. He arranged them in rows so that each row contains marble less than the preceding. Each row contains marble less than the preceding. The last row consists of one marble only, which form the vertex of a triangle. How many marbles are there in the base of the triangle? Okay. In question number 14, a boy has 231 marbles. He arranged them in a row in rows so that each row contains one marble less than the preceding. Less than the preceding. The last row consists of one marble only. Only one marble. Which forms the vertex of triangle. How many marbles are there in the base of the triangle? In the base of triangle. Solution. So the shape of the triangle will actually be this type, because in the base only one each row contains marble less than preceding, and the last row consists of one marble only. So the last row have only one marble. The second last row, two marbles, because each row contains one marble less than. So if there are two marbles, then the last row will be one, and here three marbles, and up to so on n marbles. N marble, n minus one marble, n minus two marble, so on 4, 5, 4, 3, 2, and one marble in the base of the triangle. According to given condition, the last row contain one marble. Last but one row contains two marble, and the two row contain three marbles, and so on. So the progression become as 1, 2, 3, and up to n are in arithmetic progression having difference. Common difference is 1. When there are n marbles In the base of the triangle, so marbles sum of marble is given as 231. We know that sum of n terms is equals to n upon 2, 2a plus n minus 1 of d. So Sn is given as 231. So 231 is equal to n upon 2. A is 1 plus n minus 1 and difference is also 1 because here A is equals to 1 and D is equals to 2 minus 1 which is equal to 1. Sorry, 1. And after calculating 231 is equals to n upon 2, 2 plus n minus 1. So 231 is equal to n upon 2, n plus 1. 2 minus 1 is 1. 2 multiply by 231 and we get 462 is equal to n square plus n. Here we get the quadratic equation and we find the value of n by using quadratic formula. The equation is n square plus n minus 462 is equal to 0. By using quadratic formula, quadratic formula is given as n is equal to x is equal to the given variable minus b plus minus b square minus 4ac upon 2a. Here value of a is 1. A is the coefficient of n square 1 and the value of b is also 1 coefficient of n and the value of c is constant is minus 462. So after putting the value of this value ABC in the given quadratic formula, we find the value of n. So the value of n is the number of marbles in the base of the triangle. So you can find the number of marble by yourself. Now the question number 15 is same as question number 14 like this. In this question also given the first term by 5700 and the difference is 20. And we have to find the how many days will the provisions last. So this question is also you can do with the help of some of the arithmetic progression formula. In question number 16, find the first 4 terms of the series. First 4 terms of a series of which the sum to n terms is 1 upon 2n 7n minus 1. So in this question, Sn is given as 1 upon 2 and 7n minus 1. That means Sn, we know that the in arithmetic progression, the formula of sum of n term is n upon 2, 2a plus n minus 1 of d. This we say equation number 1. In the question, Sn is equals to n upon 2, 7n minus 1. We can write this in the form 7n minus 7 plus 6, which after subtraction we get minus 1 again. Or we can write in this form as n upon 2, 6 plus 7n minus 7, n upon 2, 6 plus, we can take 7 as a common, n minus 1. If we compare this equation, this form, this expression with equation number 1, so we can write in this form also 6 is equals to 2a. 2 is in the formula, so a will be 3 plus n minus 1 of d. This we say our equation number 1, equation number 2. By comparing equation 1 and equation 2, by comparing equation 1 and equation 2, we have Sn n upon 2 is n upon 2, 2a. Here a is 3. And the d is equals to 7. This is the value of first term and the common difference. With the help of these two elements, we find the number of terms of any series. We know that the sum of the first term will be a, and the value of a is 3. And the second term t2 is a plus d. So 3 plus 7 is equal to 10. And the third term will be a plus twice of d. So 3 plus 2 into 7. 2 7s are 14 plus 3 17. And the fourth term is equal to a plus 3d. So 3 plus 3 times of 7. So this is 24. So the first 4 terms of a series is 3, 10, 17 and 24. In question number 17, if S1, S2, S3 respectively be the sum of the first N1 and 2 terms and N3 terms of an arithmetic progression, show that S1 upon N1 of N2 minus N3 plus S2 upon N2 N3 minus N1 plus S3 upon N3 N1 minus N3 is equal to 0. If S1, S2 and S3 respectively be the sum of first N1, first N2 and first N3 terms of an arithmetic progression, show that S1 upon N1, N2 minus N3 plus S2 upon N2, N3 minus N1 plus S3 upon N3, N1 minus N3 is equal to 0. So here let A be the first term and D be the common difference. In an arithmetic progression, since we know that Sn is equals to n upon 2, 2a plus n minus 1 of D. So here in the question, you are given S1 is equal to sum of the first n1 term. So n is equals to n1. So Sn1, that means S1 is equal to n1 upon 2, 2a plus n1 minus 1 of D. This we say equation number 1. And similarly, Sn2 put n is equals to n2. So Sn2 which is equals to S2 n2 upon 2 twice of a plus n2 minus 1 of D. This is our equation number 2. And after that put n is equals to n3. So Sn3 which is equals to S3 n3 upon 2 twice of a plus n3 minus 1 of D. This we say our equation number 3. From equation number 1 implies, we can take here. Equation number 1 implies we write in this in this form. Okay. So equation number 1 implies S1 upon N1 is equal to 2a plus N1 of D minus D upon 2. S1 upon N1, N2 minus N3 is equal to 2a plus N1 D minus D upon 2 into N2 minus N3. We multiply both sides with N2 minus N3. This we say our equation number 4. This is the term is given in the question. Similarly, question from equation number 2 implies S2 upon N2 is equal to 2a plus N2D minus D upon 2, and we multiply S2 upon N2 with N3 minus N1 for both sides. 2a plus N2 into D minus D upon 2 multiply with N3 minus N1. This we say our equation number 5. And after that, equation number 3 implies S3 upon N3. We multiply this with N1 minus N2 as given in the question. 2a plus N3D minus D, N1 minus N2 upon 2. This we say equation number 6. Now we add equation number 4 by adding equation number 4, 5 and 6. Equation number 4, 5 and equation number 6. We get, after simplification, 0. So this is what we have to prove, that you can do easily. Okay, in question number 18, the sum of the first n term of two arithmetic progression R as 13 minus 7n ratio 3n plus 1. Find the ratio of their first term and also their second term. The sum of the first n term of two arithmetic progression R as 13 minus 7n 3n plus 1. Find the ratio of their first term and also of their second term. Let A be the first term and D be the common difference. In first arithmetic progression, we know that the sum of n term of first arithmetic progression, sum of n terms of first arithmetic progression is equal to n upon 2 twice of A plus n minus 1 of D. Also the sum of the n terms of second arithmetic progression n upon 2. Here we take A for making difference A dash plus n minus 1 of D dash. So the ratio of the first and second two arithmetic progressions n upon 2 2a plus n minus 1 of D upon n upon 2 2a dash plus n minus 1 of D dash is equal to 13 minus 7 n upon 3n plus 1. N upon 2 is cancelled with this. So we can take 2 as a common. So a plus n minus 1 of 2d. We take 2 as a common from also denominator. So a dash minus n minus 1 upon 2 d dash is equals to 13 minus 7n upon 3n plus 1. 2 is cancelled with this 2. So we get a plus n minus 1 upon 2 d upon a dash plus n minus 1 upon 2 d dash is equal to 13 minus 7n upon 3n plus 1. This is our equation number 1. So for first term we put the value of n is equals to 1. Put n is equals to 1 in equation number 1. So we get a plus 1 minus 1 upon 2d, a dash plus 1 minus 1 of d upon 2 into d is equals to 13 minus 7. Put the value of n is 1 for first term. N is 1 minus plus 1. So a plus 0 upon a dash plus 0 is equal to 13 minus 7 is 6 and 3 plus 1 is 4. So here a upon a dash is equal to 3 upon 2. So this is the ratio of their first term. A ratio a dash is equal to 3:2. This is the ratio of their first term. Similarly, the ratio of their second term, we know that the first term is a. So we put the value of n is equals to 1 because the first term is a. The term with d will be 0. So we get the first term is as a. This is a. And for second term, the second term of arithmetic progression is a plus d. So we put the value of n minus 1 upon 2 is equal to 1 for second term. So n minus 1 is equal to 2. So here n is equal to 2 plus 1. N is equal to 3. In equation number 1 implies, put this value of n in equation number 1. The equation number 1 is a plus n minus 1 upon 2 of d upon a dash plus n minus 1 upon 2 d dash is equal to 13 minus 7n upon 3n plus 1. Here we put the value of n is 3 minus 1 upon 2 d upon a dash plus 3 minus 1 upon 2 d dash is equal to 13 minus 7n upon 3n plus 1. So a plus implies a plus 3 minus 1 is 2 upon 2 d A dash plus 2 upon 2 D dash is equal to 13 minus 7. The value of n is 3. So 3 into 3 plus 1. 2 is cancelled with 2. So A plus D. A plus D is the second term of arithmetic progression. So we find the ratio of the arithmetic progression of second term. This is our second term of arithmetic progression. A dash plus D dash is equal to 13 minus 21, 9 plus 1. For first term, we find the ratio of A upon A dash. And for second term, we find the ratio of A plus D is to A dash plus D dash. So this is the ratio of second term A plus D upon A dash plus D dash is equal to minus 8 upon 10. A plus D upon A dash plus D dash is equal to minus 4 is to 5. This is the ratio of their second term. Okay, in question number 19, the question is, these are required answer. Find the least value of n for which the sum of the first n odd natural numbers exceeds 5000. Find the least value of n for which the sum of first n odd natural number numbers exceed 5000. The odd numbers are 1, 3, 5, 7, 9 up to so on. One, 3, 5, 7, 9 up to so on. Here A is equal to 1 and the difference is 3 minus 1 which is equal to 2. And thus we know that the sum of n term Sn is equal to n upon 2, 2a plus n minus 1 of d. So we put the value n upon 2, a is 1 plus n minus 1 and the difference is 2. Sum of n odd natural numbers n upon 2, 2 plus 2n minus 2. So minus 2 cancel with plus 2. So here n is equal to n upon 2 into 2n. 2 cancel with 2. So sum of n odd natural numbers is n square. According to the question, n square is greater than 5000. So after taking root, is equal to n is greater than 17.7106. The least value of n is equal to approx 71. So this is the required answer. So we are completed our 6.2 exercise for arithmetic series. Thank you so much.